So now, on this section, that's action 6, we're going to talk about theorem 2. Now we're done with theorem 1. It was easy, you did all the problems. Now we're going to do theorem 2 and do all the problems. But before we get to theorem 2, I'll need to define some few things, right? Mm-hmm. Let's suppose we have a circle here. Can you see? Oh. Can you see the circle? Yes. And this is the center, maybe center O. Yes. Can you see it? Yes. Here's the point A, and here's the point B. What is the distance? What is this portion of the circumference between A and B called? It's an arc. It's called an arc. The distance between A and point B on the circumference, that portion or that part of the circumference is called an arc. Are you with me? Yes. This one from A on the other side, what is it called? It's also an arc. Yes. But the difference between the two are the sizes. Yes. The size of the other is small, and we call it a minor arc. It's a minor arc, this one. Minor arc. And this one is big, so we call it what? Major arc. Are you with me? Yes. Okay. So this was an arc. It is an arc, this part, right? Let's suppose we do this and we join AB. Can you see AB? Yes. So I've joined AB. This part here is a what? This part of the circle? It's an arc. Between these 2 points? It's an arc, right? Yes. And what is AB called? A chord. AB is a chord. Are you with me? Yes. Okay. So when your AB, okay. So what I want to define, I want to define the word subtend. Do you understand? Yes. I want to define the word subtend. I'll try to make it as simple as possible so that everyone understands. So when I mention the word subtend, I'm talking about an angle that is formed between 2 lines, right? Those lines are coming from somewhere. Do you understand? Can you please repeat again? When I'm talking about the word subtend, I'm talking about an angle that is formed between 2 lines. Okay. Do you understand? Yes. And those 2 lines that form an angle are coming from somewhere. For example, let's say, you see where my hands meet? Yes. There's an angle formed here. Yes. So there are 2 lines intersecting, this line and this line over here. Yes. Where are they coming from? They're coming from the elbows. Yes. So the elbows are the source of the lines that intersect to form this angle here. Yes. So what I'm saying, when I talk about the word subtend, I'm talking about an angle that is formed between 2 lines. And those lines are coming or originating somewhere. That's what I mean. For example, let's say we have A here, right? And there's this line coming here to point C maybe. And this one to point C. So, do you see angle C? Yes. Angle C, this angle here, right? Yes. It's formed between 2 lines. This line CB and this line CA. Angle C is formed by 2 lines. CB and CA. Do you guys understand? Yes. No problem. So, now, angle C is subtended, which means it is formed between 2 lines, right? But the question is, where do those lines come from? There are 2 ways you can look at it. You can say these 2 lines are coming from the chord AB. Are you with me? Yeah. Or you can say the 2 lines are coming from this arc AB. Because you can see that, okay, I'll go further in a minute. So the angle C, you can say it's subtended, it's formed by, it's originating, the lines forming C are originating from the chord AB or the arc AB. Okay. Are you guys following me? Yes. So angle C is subtended by chord AB or angle C is subtended by arc AB, which is this arc over here. Is it clear?
Yes.
Are you guys happy with this?
Yes.
Okay. So if you want to be specific, you can say minor arc AB. It's minor arc AB. Now, let me draw something similar to this. Okay. Now. Okay. So, I'll make this my center again. Okay? I'll have my A here. I'll have my B here. Are you guys with me?
Yes.
Now, let's say we subtend an angle here. Let's say it's angle D, maybe. Can you see?
Yes.
Angle D is subtended by what? It's formed by what? It's formed by this chord, Bani, AB. It's the same chord as that, because it's the same line as that, or similar chord as that.
Yes.
Are you guys with me?
Yes.
Or an arc. Which arc? It's arc AB. But now the question is it the minor arc or the major arc?
The major arc.
It is the major arc. How do you identify that? The angle that is subtended, it points on the direction of the subtending arc. Do you guys understand?
Yes.
The angle that is subtended points in the direction of the subtending arc. So, here's your angle here. You can see your angle is facing this direction. So, the arc that is in this direction is this one here. It's the minor arc. But if you look at D, the angle D is this one here. Right?
Yes.
Subtended by what? By this chord AB. But which arc is it? It's the arc in the side in which the angle is facing. This angle is facing that way. So the arc that is responsible is the major arc. So angle D is subtended by chord AB or major arc AB. So to subtend, when I say subtend, it's an angle formed between two lines. Right?
Yes.
Originating somewhere. So this angle here, I'll say this angle is angle C, right? Are you with me?
Yes.
Which is same as what? Angle AC B. Or maybe, depending on the direction you use, it's BCA. BCA. Are you with me?
Yes.
Since I'll be teaching you guys, I like moving in a clockwise direction. So I always like to move in this way when I'm naming angles. For example, I'll take ACB, for example, over BCA. If I want to mention this one, I want to move this way. So it will be CBA, not ABC. Just me. I like being consistent with that way. Are you guys following?
Yes.
So, angle C is an angle subtended by what?
By chord AB.
By chord AB or what?
By a minor arc AB.
Or minor arc AB. And angle D?
Angle D is subtended by a chord AB or a major arc AB.
Yes. So, angle D is subtended, which is formed by chord AB or this major arc AB. Is everyone happy
Yes.
with that? So, that's what I needed to define first. So, an angle is subtended by chord or major arc or arc. It doesn't matter. Even if you say chord or arc, get fun. Is everyone happy?
Yes.
Fine. So, there's this theorem that I want to work on, theorem 2. Are you guys following? So, theorem 2 states that if you have an arc or your chord, right, and it subtend angles, let's say it subtend an angle at the center and subtend an angle at the circumference. Are you with me? They say that the angle that is subtend at the center, its size will be 2 times that at the circumference. So if your chord subtends 50 degrees at the center, right? If it subtends 50 degrees at the center, you will have 25 there. Are you with me? Which means if you have 25 there, it will be doubled there. So the angle at the center is double that at the circumference. So I needed to define the word subtend so that you guys are familiar with it. Once you guys are familiar with it, then now I can go on with theorem 2, which says an angle subtended at the center by an arc or a chord is twice the angle subtended at the circumference by the same chord, of course, or same arc. Does that make sense?
Yes.
So I'll draw 3 ways in which these types of subtendents happen. And then I'll prove, I can prove all 3 of them, but I think 2 are exactly the same. So here's case number one, right? So let's say you have your A and B here, right? Let's say you want a chord or arc. You want a chord, okay, fine. Are you with me? Let's say you have your center here. So case 1 can subtend at your center like this. This is O, of course, right? Or maybe, and also subtend in the circumference like that. That is your angle C. Are you with me? So what they're saying this angle here will be double that, whatever that is. Are you with me? Which means your angle O is equal to 2 times angle C. Are you guys with me? Are you guys with me? So I've written it with this. Let's say O1 maybe. Because this is an angle as well. So O1 is the one under, this is O2 on top. Are you with me? So they're saying angle O1 is called 2 times angle C. Are you guys with me? I can go further and express this in a much more not unconventional, but a nicer way that you would not like it much. Because this is straightforward. Because I say O1 is called 2 times C. So O1 is this one, 2 times that. Are you with me? Or one would say that AOB. See, AOB. Are you with me? Is equal to 2 times what? 2 times ACB. A and ACB. Does that make sense?
Yes.
So you can see that this is the same thing.
Yes.
So even if I give you this way or give that way, and I would like to give you this way because this is the much more common way in which they like to ask it. Are you guys following? Is everyone happy?
Yes.
Questions for me?
No.
So you can see that these angles are underneath. So they're pointing that way. Can you see?
Yes.
Are they subtended by minor arc or major arc?
Minor.
It's a minor arc. Is this arc that they're facing, this arc AB down here. Are you guys happy?
Yes.
Now, I'll draw number 2, option case number 2. Can you guys see?
Yes.
So, here's your A, here's your what? Here's your B. So, let's say now they subtend an angle here, down here. I was trying to make a straight line here. So here's your O here. Are you with me? So now you can see your subtended angle C there, right?
Yes.
So, and you subtended your same thing subtended there as well. So this angle 1 and this angle 2 like we did there. So you can see this angle that is here.
Yes.
Is it subtended by what?
It is subtended by a chord AB
Okay.
and also an arc, which is the major one.
So this angle here is subtended by what? By the chord AB, right?
Yes.
Or the arc. But which arc? Put an arrow.
The major.
You'll see that this is arc, the major arc,
Yes.
because not the one down here. So it's by the major arc AB, which is this major arc that is responsible. Is everyone happy so far?
Yes.
Are you guys happy?
Yes.
No problem. Then now, if you look here at the center, your major arc, what does it subtend? Does it subtend angle 1 or angle 2?
It's the major.
Yes. No. Yes, I'm asking. You're saying now, you said C, right?
Yes.
This angle C is subtended by a major arc.
Yes.
So both of these angles, this angle and that angle, are subtended by the same arc.
Yes.
I'm saying Z. You said angle C is subtended by what?
By major arc AB.
Which is this arc up here.
Mm-hmm.
Which means if you see another angle subtended at the center, it's also subtended by the same major arc.
Okay.
You will not say now here is a major arc because it's pointing upwards, and then here wanted to change the rules. It's the same thing of subtending. It's either your major arc or your minor arc. That's it. Are you guys happy?
Yes. So angle O1 is subtended by major arc.
I didn't say that. I'm asking why you're telling me that. I'm not sure we're about to find out very soon. But if you're thinking about O1 is down here. Which side is it facing? Which is that would mean that it's subtended by minor arc. Is that what you're supposed to be having? No, they're supposed to be subtended by the same arc.
Yes.
So which means O2 is the one that is subtended by what? By the major arc. Do you guys understand me?
Yes.
Can you guys understand me?
Yes.
So your O2, this is the one that is subtended by your major arc. Because look at it, it's pointing this in your major arc direction. The same way as this. So your subtended angle should be pointing in the same direction. Should be facing the same direction. Any questions?
No questions.
Questions?
No.
So in this case, you can say the same thing, which is you're talking about angle 2, right? That angle over there. Are you with me? So you say now your O2 is equal to twice angle C. Do you agree?
Yes.
Or you can say A O B. A O B is equal to what? 2 times what? A C B.
Aren't you supposed to put 2 there?
Where?
O2.
Wait, here?
Yes.
No. So you I think what you're worried about is which one am I referring to? Is that your problem?
Mm-hmm.
In that case, I'm not going to put any one numbers there. I'll just say maybe the reflex A O B. Are you happy now?
Mm-hmm.
The reflex one, which is the big one. A O B is equal to 2 times what?
C.
A C B. Are you happy with that? So you see this looks exactly like that. So which means now I'm talking about the reflex O, which is the big one, which is the one that is more than 180 but less than 360, because that's how we define the reflex angle. Do you remember when we define the reflex angle?
Yes.
We define the reflex angle as an angle that is more than 180 degrees but less than 360, which is this. Is everyone happy so far?
Yes.
So this is case number 2. And I'll go to case number 3. Case number 3 looks like this. Can you see? Mm-hmm. So you have your center here as well. Let's say you have your A, B as well. Your A and your B as well. So you subtend here, minor arc here. Are you with me?
Yes.
And maybe somewhere here. Are you with me?
Mm-hmm.
Are you with me? Are you guys following?
Yes.
Yes. So unlike the first one, the angle C was just on top up there. So here you can see that it's more or less in line with your O there. Can you see the difference?
Yes.
You can see that the difference that now it's more or less in line. It can be down here or just above there. So this is case number 3. Are you with me?
Yes.
So in this case, I will say what? I will say this is C, right? I'll say AOB, AOB, which is this angle here. Can you see it?
Yes.
Which is subtended by what? By the minor
Minor
arc.
arc AB.
Is equal to twice what? ACB, ACB. Do you guys agree?
Yes.
Are you guys with me?
Yes.
No problem. This is it. So you can see that it's the same stuff here, but just different, it's subtended in slightly different ways. Question?
On that one, the case 2, the one that you the reflex angle. Were you gonna be wrong if you wrote to the AO2 then B?
I don't know. I've never. I don't know. Maybe you can. To be honest, I'm not very sure.
Okay.
I've never seen an angle like in an addition like that. I've never seen a number. Like for it's more like having a triangle with angle 1. More like saying triangle T1 BC. I've never seen that. It's triangle TOC or TBC. That's it. So the number I've never seen it being used. So I would not say do that. So this is the safe option. So if you want to refer to the bigger angle, say it reflects AOB. Do you guys understand? So what I'm going to do now, I'm going to prove the case number 1, prove case number 2, and case number 3. So this is the same theorem, but it's just in different case in how, depending how it is subtended. Do you understand? So it's the same, it's the exact same theorem, but it can be attended, an angle can be subtended as in case number 1, can be subtended as in case number 2, or it can be subtended as in case number 3. So we clean the board now, and then we do case number 1. Is everyone happy?
Yes.
Okay. Okay. As promised, so we're going to prove this theorem for 3 different cases, right? The first case and the second case are exactly the same. You will see why. Then the third case is slightly different. Are you guys with me?
Yes.
Okay. So, theorem 2 states that an angle subtended at the center by an arc or chord is equal to twice the angle subtended by the same arc or chord at the circumference. So what they're saying is that the angle that is subtended at the center by this arc, this minor arc of yours, will be double that subtended at the circumference. I'm not sure if you guys are get it wrong. So which is the size of this will be double of C. So what we want to prove, we want to show that the size of O will be double that of angle C. Which is the size of this angle here, angle O, will be 2 times that. So if you have a star here, this C angle should be twice that star. What? No.
2 times star.
So it should be half of star, this one. Because I'm saying now this one is bigger. Because I'm saying if this is star, then that is twice star, which is this one is bigger than this.
Okay.
So it should be half of star.
Okay.
Something like that. So our claim, which is what we want to prove, claim. We are saying that AOB, which is this angle here, is equal to the double of that angle there.
Yes.
Which is what?
AC.
Angle ACB, which is angle C, which is this is your angle, that is your angle. That's what we want to prove. Are you with me?
Yes.
So let's go with the proof. We say proof here. Are you with me?
Yes.
I'll start with the construction. I'm not sure if you get what I'm trying to say.
Yes.
I'll try with the construction. Construction. What do I do on my construction? I want to draw a diameter, right? And that diameter, I'm going to call it COB or COD. CO what?
G.
COD. Which is a diameter from C passing through O to what? To D. Which is it's a line that goes downwards here. Can you guys see?
Yes.
So in that case, I'm going to use the green color as well. So here's my diameter, COD. O. Is this still straight?
Yes.
And then this is what?
D.
This is a D. This is the only construction that I'm going to do in all of these things, the same construction. Are you guys following? And then after doing this, I'm going to look at these triangles. I have two triangles here. Can you see the two triangles?
Yes.
I have this triangle and this triangle. So I can just say this is triangle 1 here. I'll start with this one maybe. And then this is triangle 2. Are you with me? So are you guys with me? This is triangle 1, this is triangle 2. So in that case, I can say this is C1 here because this one lies on triangle 1. Can you see it?
Mm-hmm.
And this is angle C2. Are you guys with me? In a similar way. Sorry? There's no need because they're not sure. Sorry, you're saying?
1 and 2.
Yes. So in this case, if you look at this, this is a triangle, right?
Mm-hmm.
This is an exterior angle of this triangle. Can you see it? This angle here, O, this is O1 because it's on triangle 1, this one. And you can say it's O2. And let me move these twos and put them maybe here and there. So this is an exterior angle of the triangle. Do you guys agree? Because I said in order to identify an exterior angle of the triangle, it should be an extension of one side of the triangle.
Yes.
So if you look at a triangle COA and you extend CO, it goes to D. So CO is an extension to D. OD is an extension of CO. So this is C1, C2, O1 and O2. No problem. So let's look at triangle 1 now. What kind of triangle is that one?
It's an isosceles triangle.
Look, see what? OC. What is OC?
Radius.
What is OA?
Radius.
Do you see that these two are equal because they are radial? Both of them are radiuses.
Yes.
And then you have one side. So if a triangle have two equal sides, what is the triangle called? So you have an isosceles triangle there. Do you understand? So the first thing that you need to show is that you have an isosceles triangle. Outline the parts that are equal. Are you guys with me?
Yes.
So what we're going to do, we're going to point out the things that are equal. We're going to say OC is equal to what? So OC is equal to what?
OC is equal to OA.
OA. Okay, let's be clear first and tell them where we are looking.
Okay.
So in triangle what?
OC.
COA. Right?
Yes.
So OC is equal to what?
OC is equal to OA.
It's equal to OA. Right? What is the reason for that?
Radius.
We have a radius. Are you with me? So which means this angle here is the same as the angle over there. So if you're saying this is equal to this, so you said to me right now that this here is equal to this. Did you not say that?
Yes.
Because they are radii. There they are.
Yes.
So if you know that these two are equal, these two sides of the triangle are equal, you have an isosceles triangle.
Yes.
If you have an isosceles triangle, we proved when we were doing congruence that the angles opposite equal sides are equal.
Yes.
So these angles that are facing the equal sides, which is this angle here, can you see it?
Yes.
This angle is facing one of the sides, it's facing this one. This angle here, can you see this angle?
Yes.
It's facing this side. And this one here is facing that one over there. So this angle here is looking at this side, and this angle here is looking at this side, and this one here is looking at the other side. But no one cares about it. Are you with me?
Yes.
So in that case, I will say angle C1, which is that angle over there, is equal to what?
A1.
Is equal to angle A. There's no A1.
Oh, yeah. A,
It's called angle A. What will be my reason? These will be angles opposite
equal side.
equal sides. That is my reason. Because I know if I have an isosceles triangle, and if I have an isosceles triangle, then the angles that are facing equal sides are equal. Which is O1, C1 and angle A are equal.
Yes.
Now, if I add these two angles, what do I get? If I add these two angles, I'll get the exterior angle. Because an exterior angle of a triangle is the sum of the interior opposite angles.
Yes.
Do you agree, Sue?
Yes.
This is an exterior angle of this triangle. So the angle next to it is this one. So if I add the other inside opposite angles, which is that one and this one over there, they should give me O1.
Yes.
So I can say, okay, my O1 is equal to what?
C1
C1
Plus A.
plus A, angle A. What is the reason? This is an exterior. O1 is an exterior angle of a what? Of a triangle. That's it. Maybe you would like to say an exterior angle of a triangle is equal to the sum of the interior opposite angles, right? But I don't want to because I've already demonstrated that. Why should I? Maybe you can. Are you with me? Then now, the goal, we're trying to say something about O and what?
And C.
And C. So here you have O, you have C, you have A. So the goal, get rid of this A so that you are left with O and C. Because that's what you want to do at the end. But you said your O is equal to what? Your A is equal to C1.
Yes.
In the place of A, get rid of this A and put the other C there. So you get that your O1, the angle O1 is equal to angle C1 plus angle
C1.
C1, which is equal to 2 times
C1.
angle C1. Therefore, your O1 is equal to twice angle
C1.
C1. You can leave it here for now. Is it clear?
Yes.
What you did the exact same thing, but now on the triangle number 2. It's the exact same thing. Are you guys following?
Yes.
So, what do we say first? We said in triangle, what? We're going to the second triangle now. So what do we say? In triangle,
COB.
COB, we're going to say OC is equal to what?
OB.
It's called OB. Why?
Line.
These are radii. Everyone happy?
Yes.
So now let me highlight it there. And say, okay, now this is called this as well. Are you with me?
Yes.
So if you look at triangle 2, what kind of triangle is this?
It's an isosceles.
It's an isosceles because these two sides are equal. We have an isosceles triangle there. What do you know about angles opposite equal sides in an isosceles triangle?
They are equal.
They're equal, which is this angle here is facing this side, and this angle here is facing that side, which is these two angles are equal. Which means your what?
C2
Your C2
is equal to angle B.
B.
is called angle B. Because why? These are angles. Opposite what?
Equal sides.
Equal sides. If I add these two, which is I add this and this, I get an exterior angle. Because an exterior angle of a triangle, which is O2, is the sum of the interior opposite angles. That's what we said on lesson number 2, I think, or lesson number 3.
Yes.
So, which means, if I say, which is my O2 is equal to what?
C1.
C2
C2, sorry.
plus angle B. I'll say this because this is an exterior angle of a what?
Triangle.
Of a triangle. Can you see?
Yes.
Like I did there. I'm trying to talk about O and what?
And C.
So I want to get rid of this B so that I have O and C so that I can talk the same thing here. So, but I said B is equal to C2.
Yes.
So let's get rid of that B. Say O2,
Equal to C2
C2
plus C2.
plus C2. Therefore, your angle O2 is equal to 2 times your angle C2. Can you see this?
Yes.
So we have written O1 as in terms of C, right? And written O2 in terms of what?
Of C.
Of C. Look now, if I add O1 and O2, do you say I get AOB?
Yes.
Yes.
O1 and O2, they give me AOB, which is what you're looking for.
Yes.
If you add C1 and C2, you get ACB. So let's do what we want this thing. So let's add O1 and O2 so that we get what we want. Is everyone happy?
Yes.
So in that case, we'll say O1 plus O2 is equal to what? What is O1? O1 is 2 times C1 plus O2. What is O2?
2 times
2 times angle C2, right? So O1 plus O2, what does it give?
AOB.
This is AOB. There is it. O1 and O2 is the entire thing. Is equal to what? 2, take 2 as a common factor. Inside you're left with what? C1 plus C2. What is C1 plus C2?
It's ACB.
C1 plus C2 is ACB. Therefore, your A or B is equal to 2 times C1 plus C2, which is ACB. I think this is what you're looking for. This is case number 1. This is case number 1. So which means we have proved what they want us to prove. Are there any questions for me?
No questions, sir.
Please, I'm begging for questions. Questions?
No questions.
No questions.
So this is case number 1. So the case number 2, I'll just change the drawing. Are you guys with me?
Yes.
Now let's go for case number 2. You know what I'm going to do for case number 2? Jongan. I'm not going to clean any of this thing. Can you see?
Yes.
So there is your A there, there is your B there. Can you see? I'm joining them like that. This is O. Can you see? So let's say this was subtending here and there. This is our C. Are you guys with me?
Yes.
So in that case, what does it do? First thing we're going to do, construct COD. So here is COD. C. Just make the center here. COD. Can you see?
Yes.
So let's say our center is here. This is the first thing. There's no need for diameter there for this thing. It will just confuse us. Can you guys see?
Yes.
Coordinate of it. So in the first case, it was the minor arc subtending. Now it's the major arc subtending. Can you see? See here? Everyone hear me?
Yes.
So I'll say this is C1, this for this triangle, this is C. And I was using green ink or maybe red. So C1 here, C2, C1 this side, C2 this side. Is everyone happy?
Yes.
So the first thing, I look in triangle COA. This is my A, and this is my B. The first thing, I looked in triangle COA. Where is COA? It's this one here. COA. Can you see? COA.
Yes.
Can you see? I said OA is called OC, which is your OA is equal to OC. Can you see this is the same proof?
Yes.
OA is called OC, it's a radian. And then I went on to say that angle C1 will be equal to angle A. Your angle C1, because this and this are equal. That's what it said there.
Yes.
So this angle here is equal to this angle here. Because these are angles opposite equal sides. So I said A is equal to C1. This A is equal to C1. Do you see?
Yes.
And then I went on to say that now, if this O1 here is an extension, I said O1 is an extension of CO. Can you see? And your D, look, be careful. I want to make this so your D should be sitting there. So now O1 is an extension of this triangle, of this side CO. Can you see?
Yes.
So it's an exterior angle. So if I want an exterior angle, should be C1 plus angle A.
Yes.
Angle C1 plus angle A should be the sum of the opposite interior angles.
Yes.
So, which is what I had there. Do you guys see? Now, because I'm talking about O and C, I want to get rid of that A over there, but I know they're equal, so I'm going to put this, and there it is. Same proof. Do you guys follow this proof?
Yes.
Same thing. Do you want me to explain that as well?
No.
Because you'll be looking at this one over here and say, okay, your OC is called OB. There is your OC. Who is it? OC is called OB, which is a radian. Here they are. Right? And then I'll say now, my angle B is called angle C2. Angle B is called angle C2 because these are angles opposite equal sides. And then now, I know if I add them, I'm going to get an exterior angle, which is O2, which is over there, because an exterior angle of a triangle. But because they have O and C and B, I want to get rid of B because I'm interested in talking about A and C. The same way. This is the same proof. Do you want me to clean this and rewrite it? It's the exact same thing. Because the difference is that you are subtracting C there, but you are subtracting down here now. That's the only difference. Now, I'm going to case number 3 because I don't think I need to be entertaining this. Then we'll be done here. So, let's go to case number 3. I'm going to clean the entire board now. Okay. So now we're going to do case 3. Case 3 looks like this. Are you guys following? This is case what?
3.
Case 3. Right? Okay, I'm not very happy with this diagram. Actually, let me work with it. So, on this case, I'm trying to prove what on this thing? I'm trying to prove that, I'm trying to prove the same thing. Same thing. Claim. My claim is that my AOB, which is this angle here, can you see it? This angle here is equal to 2 times what? ACB, which is twice this angle over here. That's the same claim. Are you guys with me? Let's go to what? To the proof. What do we need first? It's a construction. Same construction. What did we construct there?
The diameter.
Construction. I said draw. Diameter what? COD. Here's C. Here's O. I think D is somewhere here. Do you guys agree?
Yes.
Do you guys agree?
Yes.
Once I do that, I have 3 triangles. I have 2 triangles like I did previously. Triangle number 1 is here. Is COA. COA. Here is it.
Okay.
And triangle number 2 is COB. Here is it. Like I did there. So it's COA and COB. Are you with me? No problem. So I can split the way I split the things there and say this is my C1, this one here. Can you see?
Yes.
And this one down here is my C2. Do you guys agree?
Yes.
And if you're looking, this is 1 here. Looks like a 2. So this is a 1 here. So if the angle, this angle here is C1, and this angle here is C2. Is everyone clear now? So now, I have those interior angles there. Let's go look at the exterior angles. So, if I'm looking at COA, can you see that this is an exterior angle of COA, this one? This one here. Because look, I extended OC to this, so here's an exterior angle of COA. Do you agree?
Yes.
Now let's look at the second triangle. What is it?
COB.
COB. Right? Oh, wait. Where is this triangle? Oh, it's COB. Can you see it?
Yes.
So an exterior angle of it is the entire thing here. This is exterior angle. So this is angle 01 here. This is exterior for the small one. This is angle 2 for the big one. Because look, if you're saying COB, And do you see angle COB?
Yes.
Fine. So if you extend your OC to this, now your exterior angle will be that one. Do you agree?
Mm-hmm.
Is everyone happy?
Yes.
Say you're happy?
Yes, I'm happy.
Do you want me to explain this again?
No.
Okay. Now, let's go to our triangles now. We're going to do the same thing. I'm going to start with the triangle number 1, the small one, COA. In triangle what? In triangle COA, what do we say? Compared to the sides, again. OA is equal to, in triangle COA, which triangle COA, your OA is equal to OC.
Yes.
Why? These are radii. Right?
Yes.
What else do we say? So in that case, C1 is equal to, because these two are equal. We just said these two are equal. So which is your C1 is equal to angle A. So your angle C1 is equal to angle A. What is the reason? These are angles opposite equal sides. Is everyone happy? No problem. Then we go further. Sorry? Which is O1, which is the exterior angle. O1, which is the exterior angle. It's equal to angle C1 plus angle A. You say what? This is an exterior angle of a triangle. But we want to talk about O and A. Because that's what O and A. O and C. Let's get rid of that A and put A equal to C1, put that C1 there. You get that the O1 is equal to 2 times angle C1. And you're done here. Are you happy?
Yes.
Is everyone happy so far? Do the same thing, but on the other triangle. What do we say? In triangle COB. Triangle, your OB, which is this line here. OB is called OC. What is the reason? These are radii. What else?
Then angle C.
Angle C2. Angle C what?
It's the whole C.
Oh, sure, sorry. So in that case, because to differentiate between the two, the whole C, let's call it angle C2 then. Do you guys understand? To differentiate between the two angles. So this entire angle is called C2. So in that case, your angle C2 is equal to angle B. So this is equal to that. Why? These are angles opposite equal sides. Is everyone happy?
Yes.
In that case, we can say, okay, now if we add these two, this angle and this angle, get the exterior angle, O2. So our O2 equal to angle C2 plus angle B. What is it? Exterior angle of a triangle. O2 is equal to 2 times C2. Because we're going, this is equal to this, so you just substitute that the way you did in the first one. Then we have O2. But we're looking for this triangle here. Right?
Yes.
Are we not looking for that triangle?
Yes. Which one?
AOB.
AOB.
Yes.
How do we find AOB then? How do we find this angle here? How can we express this angle here between these two angles?
How can we express angle AOB?
Yes, this part. We want to express this part, AOB, this angle here, as O1 and O2. We want to write this part here, this angle here, as O1 and O2. You are doing this in analytical geometry.
Aren't you going to say that O angle AOB is equals to just the O2 minus the
Exactly,
O1?
exactly. So, if you want this angle here, you say the entire angle minus that small part that you don't want. Should be O2 minus O1. We're trying to get AOB. So you want just on the part underneath. So from this entire angle, remove the part that you don't want, which is O1.
I want the shaded angle.
Yes, because we want to say this angle is twice that one. So we want this one here, this part, AOB, which is the one, this one.
Okay.
So if you want it, from the entire O2, we just remove this O1, so that we're left with this part there, which is. So in that case, we say what? O2. We'll just say O2 minus O1. Is everyone happy?
Yes.
O2 was what? Twice C2 minus 2 times C1. This minus this, that is your AOB. So this is your AOB is equal to 2 times C2 minus C1. So AOB is equal to twice C2 minus C1. C2 is the entire angle. Can you see?
Yes.
Minus C1, you're minusing the other part. So you're left with the small part, which is your ACB. ACB. You're done with this proof. This is case number 3. Do you see the construction is exactly the same?
Yes.
Everything is exactly the same, except the end. Because at the end, you just have to see that your O2 is the entire angle. Measured from that, both of these angles are measured from that construction of yours. The same way the other exterior angles there were measured from, or interior angles were measured from that construction. This is case number 2. I'll do an example or two, and I'm done with this thing. Is this difficult?
No, it's not.
Okay. So now we're going to do this example 1, right?
Yes.
They are saying you are given a circle with center O, right? With points A, B, C on the circumference of the circle. Can you see that?
Yes.
We have a circle with center O, A, B, and C are points on the circumference of the circle. They are saying, now, angle A is equal to 43 degrees. Can you see?
Yes.
Angle A is equal to 43 degrees. They are saying now, calculate the size of O1. So, they want to find the size of O1. So what is this? What is O1? O1 is this angle over here. Can you see it?
Yes.
You can see which, is it facing the minor arc or major arc?
Minor arc.
It's looking downwards, look. It's facing the minor arc. Same as that one. So both of these are subtended by the minor arc or your chord, CD. CB. Right?
Yes.
No problem. So they want O1. O1 is a what? Is an angle subtended at the center. We just proved theorems about it.
Yes.
We said the angle subtended at the center is twice the angle subtended at the circumference. Are you with me?
Yes.
Which means COB, right, is equal to what?
Twice
2 times what?
CAB.
CAB. What is the reason for it? We will say what? Angle at center equal 2 times angle at circumference. So circum. Is it clear? So we're saying angle at center is called twice the angle at circumference. This angle at center is called twice the angle at circumference. 2 times angle at circumference. Are you guys following? In that case, we want O1. So which is O1 is equal to twice what? Twice angle A. Are you following? Which is 2 times what? 43, which is what?
86.
86 degrees. I'm not sure if you guys are following.
Yes.
This is the first one, A. What are they saying at B? They are saying calculate the size of B1. So we have 86. Put your 86 there. They want us to find the size of what? Of B1. So we have C1 and your B1 over there. They want us to find what? The size of what?
B1.
Of B1. If you look at B1, B1 is sitting on a triangle, COB.
Yes.
Are you with me?
Yes.
But now, what kind of triangle is COB? Let's go and find out. We'll say in triangle, COB, your OC is equal to what?
OB.
It's called OB. Why?
Right.
These are radii. Are you following?
Yes.
No problem. What else do you know? So what kind of triangle is this?
Yes.
We have an isosceles triangle. What else do you know?
Opposite angles are equal.
We know that angles opposite equal sides are equal. Which means we'll say our angle, C1, it's called angle B1. These are angles opposite equal sides. Are you with me? But we're looking at this triangle. We want B1. We know that if we add all the angles in that triangle, what do we get?
180.
We get 180 because the angles in the triangle are supplementary.
Yes.
So we're still in the same triangle. So we'll say C angle C1 plus angle B1 plus angle O1 is equal to?
180.
These are 180. Why? Sum of angles
Triangle.
in a triangle. Are you with me? Then we go to substituting. C1 and B1, we said they're equal.
Yes.
Instead of having both C1 and C as unknowns, we can just have a double unknown, which is B1.
Yes.
So instead of C1, say just B1 plus B1 plus 86 degrees is equal to 180 degrees. Then B1 plus B1 twice B1 is equal to 94. Because you say this minus this.
Yes.
Then divide by 2, divide by 2. What do you get? Your B1 is equal to what? 47 degrees. So you get that your B1 is 47,
Yes.
and so is your C1, 47. Oh, 47.
Yes.
There they are. This is what you'll be doing for the next 2 days. Is this difficult?
No.
Then if you have any questions, do you have any questions for me? Now in that case, the class is adjourned, and I hope this does make sense to you as it does to all of us. Thank you for watching.
Subscribe.
Yeah, they should be subscribing. Remind them. So we're done here.